What if the most powerful company in the electric vehicle world just pulled the rug out from under the entire industry? What if quietly and without fanfare? Tesla has been preparing a technological move that could rewrite the rules of global manufacturing as early as 2026. According to confirmed statements from Tesla itself, engineers inside the company have been working for more than 2 years on a next-generation electric motor that removes one of the most sensitive dependencies in the EV world, rare earth metals. This is not speculation, and it is not a leak. It is a strategic shift that could change cost supply chains, geopolitics, and competition across the entire automotive sector. The context matters. This development comes at a moment when Tesla is no longer the uncontested leader it once was. Last year, Tesla delivered roughly 1.8 million electric vehicles worldwide, a historic number by any standard, but for the first time, growth slowed. At the same time, the global EV market surged past 17 million total sales, pushing Tesla's market share down to roughly 10%. In simple terms, the market grew faster than Tesla did. Competition has intensified sharply. Chinese manufacturer BYD sold more than 3.8 million vehicles in the same period, overtaking Tesla in several quarters. European and Asian brands such as Volkswagen, BMW, Hyundai, Kia, and Mercedes have expanded their electric lineups aggressively, offering lower prices, diversified designs, and increasingly reliable charging ecosystems. Tesla remains strong, but the era of effortless dominance is over. This pressure explains why Tesla's latest announcement has triggered such intense reactions across the industry. At the heart of the issue is rare earth material. Nearly every modern electric motor relies on rare earth magnets made from elements like neodymium and dysprosium. These materials are expensive, difficult to extract, environmentally damaging, and critically heavily concentrated in one country. Around 90% of global rare earth processing is controlled by China. Any disruption, regulation change, or price shock instantly ripples through the global EV supply chain. Tesla's plan aims directly at this vulnerability. The company is developing a motor that does not rely on rare earth magnets at all. If successful, Tesla would no longer be exposed to fluctuating rare earth prices, geopolitical leverage, or supply bottlenecks. Production costs could fall sharply, and manufacturing would become faster and more predictable. According to Tesla engineers, this new motor is not a downgrade. On the contrary, it is designed to be cheaper, more durable, and at least as powerful as current motors. Tesla claims it will withstand long distances, high speeds, and extended use with lower maintenance demands. If these claims hold true, the impact would be enormous. Industry analysts cited by international outlets such as Reuters and Automotive News describe this move as one of the most disruptive motor strategies in decades. Removing rare earth materials does not just affect Tesla. It threatens the cost structure of every major EV manufacturer that still depends on magnet-based motors. But here is the real cliffhanger. Tesla is not doing this as a research experiment. The company has tied this technology directly to its future mass-market strategy, including the long-rumored affordable compact vehicle expected around 2026. If Tesla can truly deliver a cheaper, stronger motor without rare earth dependence, the balance of power in the EV market may be about to shift again. And the companies watching this development know one thing for certain. If Tesla gets this right, the race changes overnight. So the question is no longer whether this motor matters. To understand why Tesla's new motor strategy is causing such unease across the industry, it is necessary to look deeper at what rare earth dependence really means and why escaping it is so difficult. For decades, rare earth magnets have been considered the backbone of electric motor performance. They deliver high torque, compact size, and reliable efficiency. Almost every major EV on the road today relies on this same foundation. The problem is not technology. The problem is control. Rare earth elements are not actually rare, but they are extremely difficult and dirty to process. Mining and refining them damages soil, contaminates water, and releases toxic byproducts into the air. Entire regions have been scarred by rare earth extraction. This is why many countries reduced or abandoned domestic production, leaving the supply chain concentrated elsewhere. Today, roughly 9 out of every 10 rare earth components used in EV motors come from China. This concentration has created a silent risk that most consumers never see. Any change in export rules, trade tensions, or environmental policy can instantly drive up prices or restrict access. Over the past few years, rare earth prices have fluctuated wildly. For automakers operating on thin margins, that volatility is dangerous. Tesla understands this vulnerability better than most. The company has already faced supply chain shocks from batteries, chips, and global logistics. As competition intensified, Tesla could no longer rely solely on software branding or charging networks to stay ahead. Cost reduction became a strategic necessity, not an option. This is where the rare earth-free motor becomes more than a technical upgrade. It becomes a strategic weapon. According to Tesla's own disclosures, the company is redesigning the motor from the inside out. Instead of relying on permanent magnets, the new system uses advanced coil arrangements and electrical field control to generate torque. In simple terms, electricity replaces magnetism as the primary driving force. This allows Tesla to use common industrial materials such as steel and copper, which are cheaper, widely available, and easier to recycle. The implications are massive. Removing rare earth magnets simplifies manufacturing. It eliminates multiple production steps, reduces material handling, and shortens assembly time. Factories can scale faster. Costs drop not by small margins, but potentially by double digits. Industry estimates suggest motor costs alone could fall by 20 to 25%. For Tesla, this reduction directly supports its most ambitious goal: mass affordability. The company has been clear that future growth depends on reaching ordinary households, not just premium buyers. Analysts point to the upcoming compact model, often referred to as Model 2, as the first vehicle designed around this new motor philosophy. Meanwhile, competitors face a difficult reality. Brands like Toyota, Volkswagen, Hyundai, and BYD have invested billions into motor designs optimized around rare earth magnets. Switching away is not a software update. It requires new factories, new tooling, and years of testing. During that transition, Tesla could widen the gap. BYD presents a unique case. While it currently outsells Tesla in volume, it remains deeply integrated into the same rare earth supply ecosystem. If Tesla escapes that dependency while maintaining performance, BYD and others will be forced to react quickly or risk falling behind on cost. And this is where tension builds. Because Tesla is not just reducing costs, it is changing the rules of supply chain power. A motor that does not depend on rare earth materials means independence from geopolitical pressure, fewer regulatory surprises, and long-term stability. The industry sees the direction. What remains unclear is timing. Tesla claims this technology will reach production within the next 2 to 3 years. If that timeline holds, the countdown has already begun. The question now is not whether rare, earth-free motors will become the future, but whether Tesla will be the only company ready when that future arrives. As Tesla pushes forward with its rare, earth-free motor, attention is shifting from strategy to execution. Designing a motor without permanent magnets is not just a bold idea. It is a complex engineering challenge that few companies have been willing to attempt at scale. This is where Tesla believes its advantage lies. Traditional electric motors rely on embedded magnets inside the rotor to create a constant magnetic field. This design is powerful but rigid. Magnets add weight cost and long-term degradation risks. Over time, rare earth magnets slowly lose strength, especially under heat and stress. Tesla's new approach removes this weakness entirely. According to engineers familiar with the project, Tesla is developing a magnet-free rotor that generates its own magnetic field, once electricity flows through the system. Carefully timed electrical currents and advanced coil geometry replace permanent magnets. The result is a dynamic magnetic field that adapts in real time, improving efficiency under different driving conditions. This shift changes everything inside the motor. Without magnets, the rotor can be lighter and structurally simpler. Tesla is using high-grade steel alloys, precision copper windings, and silicon-based components that tolerate heat far better than traditional magnet systems. This allows the motor to operate at higher speeds for longer periods without overheating. Cooling becomes critical in this design, and Tesla has addressed it directly. The company is integrating an advanced liquid cooling system that circulates coolant through critical motor zones. Unlike older designs, heat is removed evenly, preventing stress points that shorten motor life. This directly improves durability and reliability. One of the most common fears is performance loss. Critics argue that removing magnets reduces torque and acceleration. Tesla strongly disputes this. The company claims that new inverter software, smarter current control, and redesigned winding patterns allow the motor to match, and in some conditions, exceed the performance of magnet-based systems. Noise and vibration have also been carefully addressed. Magnet-free motors can produce irregular vibrations if poorly balanced. Tesla reportedly redesigned the rotor mass distribution and coil synchronization to minimize these effects. The goal is a smoother, quieter driving experience, especially noticeable at highway speeds. Durability may be the most important advantage of all. Without magnets that degrade over time, the motor maintains consistent output for much longer. Tesla estimates a functional lifespan of 10 to 15 years with minimal performance loss. For consumers, this translates into lower maintenance costs and higher long-term value. Manufacturing efficiency is another critical factor. Eliminating magnets removes several labor-intensive steps from production. There is no need for magnet shaping, precise embedding, or complex bonding. Assembly becomes faster and less error-prone. This aligns perfectly with Tesla's push toward highly automated factories. Industry experts note that this design philosophy mirrors Tesla's broader manufacturing strategy. Simplify components, reduce dependencies, scale faster than competitors can adapt. According to reporting from Automotive News, Tesla's factories are already being reconfigured to support higher motor output using fewer materials. The deeper implication is not just technical superiority, it is time. Every month Tesla spends refining this system is a month competitors fall further behind. Re-engineering a motor platform is not a short-term fix. It can take years, and this leads to a critical moment. Tesla's motor is no longer theoretical. It is moving toward production readiness. The question now is not whether it works in a lab, but how quickly Tesla can deploy it across real vehicles before rivals can respond. Because once the first magnet-free Tesla hits the road, the industry will face a new reality. And by then, it may already be too late to catch up. The true shockwave of Tesla's rare earth-free motor is not limited to engineering or performance. Its most disruptive impact may be felt far beyond factories and showrooms, reaching deep into global supply chains, geopolitics, and industrial power balances that have remained largely unchanged for decades. For years, rare earth materials have quietly become one of the most strategic resources in the modern economy. Electric vehicles, wind turbines, military systems, and consumer electronics all depend on them. Control over rare earth processing has translated into leverage. Governments understand this. Corporations feel it. And Tesla's move threatens to weaken that leverage dramatically. If Tesla succeeds in removing rare earth metals from its motors, it reduces dependence on a supply chain dominated by a single region. This is not just about cost stability. It is about strategic independence. Automakers have learned hard lessons from recent years when geopolitical tensions and trade restrictions disrupted everything from chips to batteries. Tesla's new motor is designed to insulate the company from those shocks. Analysts following the industry believe this could trigger a chain reaction. As one Reuters report notes, EV manufacturers are among the largest consumers of rare earth magnets. If even one major player significantly reduces demand, pricing structures could shift. Over time, this may reduce investment in rare earth mining, impacting economies that rely heavily on those exports. This is where the pressure intensifies for Tesla's competitors. Companies like Volkswagen, Toyota, Hyundai, and Mercedes have built entire motor platforms around rare earth magnets. Transitioning away would require massive reinvestment, new designs, new factories, new supplier relationships. This is not a change that can be made quickly or cheaply. BYD faces a particularly complex dilemma. While it benefits from proximity to rare earth processing, it also competes directly with Tesla on price. If Tesla lowers production costs while maintaining performance, BYD may be forced into a costly technological pivot or aggressive price competition. Either path carries risk. For consumers, the implications are profound. A motor that is cheaper to produce allows vehicles to be sold at lower prices without sacrificing margins. This could accelerate EV adoption, especially in regions where cost remains the primary barrier. Markets in Southeast Asia, South America, and parts of Europe could see faster transitions as affordable models become viable. Environmental impact adds another layer. Rare earth mining is among the most environmentally destructive industrial processes. Reducing demand means less land degradation, less water contamination, and fewer toxic emissions. Tesla's move could make electric vehicles closer to the environmental ideal they are often claimed to be. But there is also a warning hidden inside this shift. Supply chains do not disappear overnight. If Tesla pulls ahead while others lag behind, the industry may face a two-tier market. One side operating on modern, flexible systems, the other trapped in older, cost-heavy structures. This imbalance could reshape competition faster than expected. Smaller manufacturers may struggle to keep up. Consolidation could accelerate. Partnerships may form out of necessity rather than choice. And Tesla is fully aware of this momentum. The company has repeatedly stated that its future depends on scale, speed, and independence. The rare earth-free motor aligns perfectly with that vision. Yet the biggest uncertainty remains unresolved. Tesla has changed the strategic equation, but strategy alone does not guarantee victory. Execution timing and public trust will determine whether this becomes a revolution or a costly experiment. The world is watching closely, because if Tesla crosses this threshold successfully, the consequences will ripple far beyond electric cars. They will redefine who controls the future of industrial technology. As Tesla moves closer to bringing its rare earth-free motor into real production, the conversation is shifting again, this time toward cost performance and what this means for ordinary drivers. Because no matter how advanced a technology may be, its true impact is measured by what reaches the road and at what price. Cost reduction sits at the center of Tesla's long-term strategy. Rare earth magnets represent a significant portion of motor expenses, not only because of material prices, but because of the complex manufacturing steps required to integrate them. By removing magnets entirely, Tesla simplifies the motor into fewer components, fewer failure points, and faster assembly. Industry estimates suggest that eliminating rare earth materials alone could reduce motor production costs by as much as 20 to 25%. That saving does not stay confined to the factory floor. Lower motor costs ripple through the entire vehicle structure. Cheaper motors reduce overall vehicle pricing. Improve margins or allow manufacturers to reinvest savings into better batteries. Improved safety systems and more efficient production lines. For Tesla, this opens the door to something it has promised for years, a truly affordable mass-market electric car. Much of the industry believes this motor is being designed specifically with Tesla's upcoming compact vehicle in mind. Often referred to as Model 2, this vehicle is expected to target a price point comparable to traditional gasoline cars. If Tesla can deliver an affordable EV without sacrificing performance, the psychological barrier for millions of buyers could disappear almost overnight. Performance, however, remains the key question. Skeptics argue that a magnet-free motor may struggle to deliver the instant torque drivers expect from electric vehicles. Tesla counters this concern with confidence. According to internal projections, the new motor will deliver equal or better acceleration through smarter electrical control, optimized winding geometry, and next-generation inverter systems. Efficiency is another critical factor. Tesla claims the new motor will consume less energy per mile, extending driving range without increasing battery size. This is especially important for affordable models, where battery cost remains one of the largest expenses. A more efficient motor reduces battery demand, further lowering vehicle cost. Durability also plays a central role. Traditional rare earth magnets degrade slowly over time, especially under high heat and heavy load. Tesla's magnet-free design avoids this problem entirely. With fewer components subject to long-term decay, the motor maintains consistent performance for years. This could significantly reduce maintenance costs and increase resale value, two concerns that matter deeply to older buyers and long-term owners. For consumers over 40, reliability often outweighs novelty. Tesla's promise of a motor that lasts a decade or more with minimal maintenance directly targets this mindset. It positions the vehicle not as a gadget, but as a dependable long-term investment. But not everyone benefits equally. Competitors now face an uncomfortable choice. Either accelerate development of similar technologies at enormous cost, or accept higher production expenses and shrinking margins. Neither option is attractive. Some may attempt incremental improvements, but without eliminating rare earth dependence. Those gains may be limited. This creates a widening gap. Tesla is not just innovating. It is resetting expectations for what an electric vehicle should cost, how long it should last, and how independent it should be from global supply shocks. The market reaction has been cautious, but alert. Investors, suppliers, and rival automakers are watching closely, because once Tesla proves this system at scale, there is no going back. And this leads to the most pressing question yet. Can Tesla execute this transformation fast enough to stay ahead, or will the weight of expectations slow it down at the final moment? The answer may determine not just Tesla's future, but the future shape of the entire electric vehicle industry. As the industry looks toward 2026, Elon Musk's broader vision becomes impossible to ignore. This rare earth-free motor is not an isolated innovation. It is one piece of a much larger strategy aimed at redefining what Tesla represents in the global automotive landscape. Musk has made it clear that the future of Tesla is not limited to premium electric vehicles. His objective is scale, affordability, and independence. For years, Tesla was viewed as a technology leader rather than a volume manufacturer. That perception is now changing. Musk wants Tesla to become the world's most efficient mass production automaker, capable of delivering millions of vehicles at prices comparable to gasoline cars. The rare earth-free motor directly supports that goal by reducing complexity, lowering costs, and stabilizing the supply chain. Tesla's factories are already being prepared for this shift. Automation levels are increasing, component counts are shrinking, and production lines are being redesigned around simplicity. By removing rare earth magnets, Tesla eliminates one of the most unpredictable variables in modern manufacturing. This allows production planning years in advance without fear of sudden shortages or political interference. The timing is critical. Global EV adoption continues to rise, but affordability remains the biggest obstacle. Governments are gradually reducing subsidies. Consumers are becoming more price sensitive. A cheaper, more durable electric vehicle could arrive at exactly the moment the market needs it most. At the same time, competitors are under pressure. Traditional automakers move slowly, constrained by legacy systems and massive sunk investments. Even fast-moving rivals must navigate regulatory approvals, supplier contracts, and internal resistance to radical change. Tesla's advantage lies in its willingness to redesign entire systems rather than optimize outdated ones. Yet, risk remains. Scaling a new motor design is never simple. Any failure at production level could delay launches and damage confidence. Tesla's reputation for innovation is strong, but expectations are higher than ever. A misstep now would echo across the market. Still, the direction is clear. If Tesla succeeds, the electric vehicle will become cheaper, cleaner, and more accessible than ever before. Rare earth dependence, once considered unavoidable, may soon look like a relic of the past. And that possibility changes everything. So now, the question turns to you. If Tesla truly delivers a rare, earth-free motor by 2026, does it become the company that finally brings electric vehicles into the mainstream? Or will competitors catch up before the gap becomes irreversible? Would you trust a magnet-free motor that promises lower cost, longer life, and fewer supply chain risks? Or do you believe the industry will resist such a shift for longer than expected? Share your thoughts in the comments below. If this analysis helped you understand where the EV market is heading, take a moment to subscribe and stay informed. The next wave of automotive change is already forming, and the decisions made today will shape how we drive for decades to come.